Hey there and welcome. Today we are going to talk about solving multi-step equations using distribution, combining like terms, and then using inverse operations. Let's go ahead and get started. The first thing we have to talk about is what is distribution? And distribution just means that we're going to take the number outside of the parentheses and multiply it to everything inside the parentheses. So let's go ahead and look at some examples. Alright, so this first example that we have is -2 times the quantity m minus 15. And we can see that this -2 right here is outside the parentheses. And it's stuck to the parentheses, so it needs to be multiplied to everything inside. So I'm going to multiply that 2 to that -2 to the m, which gives me -2m. Then I'm going to multiply that -2 to the -15, because that's still inside the parentheses. A negative times a negative gives me a positive, and 2 times 15 is 30. Now, this example does not have an equal sign, so I'm not solving for m here. I'm just simplifying. So, this problem is done because -2m and positive 30 are not like terms. I can't combine them anymore. Let's look at another example. So this time I have 9 minus the quantity 20m plus 9. Now this one's a little bit tricky because we have this negative sign that's actually right next to our parentheses. There's an invisible 1 right in between that negative and that parenthesis that we need to squeeze in there because that's what we are actually distributing. The 9 is not next to the parentheses. So I'm going to distribute the -1 to everything inside the parentheses. Now that first 9, I didn't do anything to, so I'm going to bring it down. -1 times a positive 20m gives me a -20m, and a -1 times a positive 9 gives me a -9. Now, I need to check to see if I have any like terms. And I happen to have this positive 9 here and this -9 here. And those are like terms. Those can be combined. So I need to combine them together. And a positive 9 and a -9 give me 0. So those eliminate. And all I'm left with is -20m. And so that would be my final answer. Again, this doesn't have an equal sign, so I'm not solving for the value of m. Alright, our next example, 2/3 times 7/3 plus 2/3 m. Don't let the fractions scare you, right? They're just fractions. They're not a big deal, right? It's the same exact process. That 2/3 is going to be distributed to that 7/3. And when we multiply fractions, remember we multiply straight across. So it's 2 times 7, which gives me 14. And then 3 times 3, which gives me 9. And then we need to distribute to that other part of the parentheses, which is 2/3 times 2/3 m. So 2 times 2 is 4, and 3 times 3 is 9, and then we still have that m in there. Don't drop your variables. Now, even though our rules of fractions say they have to have the same common denominator in order to add them, we still have to look to see if these are like terms. And 14/9 and 4/9 m are not like terms. Right? One has a variable, one does not. So this problem is actually done. It's as simple as that. Let's look at one more example before we start solving. This one's a big one. 16m plus 3 times the quantity -15m minus 2 plus 8m minus 21. Now again, we are only distributing what is directly outside those parentheses to everything inside the parentheses. This 16m is not touching the parentheses, so that's just going to go straight down. But this 3 is touching the parentheses. So I need to do 3 times -15m, which is -45m, I need to do 3 times negative 2, which gives me negative 6, and 3 times 8m, which is 24m. And then my parentheses close, which means I'm no longer distributing, but that negative 21 still needs to come down. All right, now I got to find all my like terms together. So I'm going to group all of my m's first, all of my variables first. I'm going to scroll this just a smidge. So I have 16m, negative 45m, positive 24m. All of those are like terms together, and how you choose to combine those is completely up to you. I personally like to add all of my positives together first, and then add all of my negatives together first, and then subtract at the end. But it's completely your choice, so long as you are doing the correct operations. So I know that 16m and 24m are going to give me 40m. Right, so when I combine 16m and 24m, those give me 40m. And then I still have that minus 45m. Ooh, you can't see that. 40 minus 45 is going to give me negative 5. So all of that combined gives me negative 5m. Negative 6 and negative 21 are my other like terms. I'll use a different symbol instead of the bracket. I'll use a squiggly to show that they're different. Negative 6 and negative 21 are like terms. They don't have a variable. They are just constants. So I'm going to combine those together. Since they are both negative numbers, I'm going to add them together. They're also both negative numbers, so my answer is going to stay negative there. So minus 27. Again, there's no equal sign. I can't solve. I don't know what m equals, but we have simplified it to the greatest of our abilities. We no longer have any like terms to combine together. Now let's actually solve some. So here's the first one that we're going to solve. We're going to start with that distribution of that negative 4. It's negative in front, so we have to distribute the negative. So we have negative 4 times a positive 2k, negative 4 times negative 5. But again, that 3 is not being distributed, so that's just going to come straight down. Negative 4 times positive 2k is negative 8k. And negative 4 times negative 5 is positive 20. Equals 71. Now I'm going to combine my like terms, which in this case is positive 3 and positive 20, which gives me 23. That minus 8k is still in there, and that equals 71. All right, from this point, I like to use my circle of don't touch, which in this case is my negative 8k. So I'm going to circle that, and I have to get rid of what is outside that circle, which in this case is that positive 23. So the inverse of that is to subtract 23 from both sides. Whatever you do to one side of the equal sign, you got to do to the other. 23 minus 23, those are going to eliminate. We're going to bring that negative 8k down. And 71 minus 23 gives us 48. Now our next step is to get that k all by itself. The only way to do that is to divide both sides by negative 8 because it's being multiplied. And you end up with k equals negative 6. It is always a good idea to take your answer, plug it back in, and make sure that you got the correct answer. So make sure that you do that. Now this was the traditional way of solving this problem, right? The standard algorithm that every math person knows how to do. I'm going to go ahead and do this problem again using the box method because I know that it's really helpful for a lot of people. Now when doing the box method for this problem, you still need to make sure that that distribution happens first. So I still am going to bring that 3 down. I'm still going to distribute that negative 4 to the positive 2k and to the negative 5 to get that equals 71. Once all of your distribution is good, then you can go ahead and make your boxes. So first I'm going to look to find out how many places I have a variable, and it's just one, so this box is going to be pretty simple. Let's make that go in half. And then I'm going to look to see how many places I have constants, which is 3. So this one needs to be broken up into those 3 sections. So my variable is going to go here. Since there's only one variable, the top and the bottom are going to be exactly the same. But since I have this positive 3, it crosses over that line, so it turns to a negative 3. Positive 20 crosses over the line to become negative 20. And positive 71 does not cross the line, so it stays as a positive 71. So now I have all of those like terms grouped together already. So it's a little bit different in the traditional method where you have to find it all. We put them all together on the same side of the line. So negative 3, negative 20, positive 71 gives us that positive 48. So from here we have negative 8k equals positive 48. We still need to divide both sides by negative 8 to get that k equals negative 6. Again, whichever method you choose is completely your choice. Just make sure that you showed all of your work for it. Alright, let's do one more example real quick. Alright, for this example, we're going to start by distributing 12 times 2k, which is 24k. And then 12 times 11, which is 132, equals 12 times 2k, which is 24k, plus 12 times 12, which is 144. And whether you choose the traditional method or the box method is completely your choice. I'm just going to do this one real quick with the box. I have 2 places that my variables show up. So I'm going to split that box in half. And then I have 2 places where constants show up. So I'm going to split that one in half as well. My 24k up here is going to stay positive, but this one crosses the line, so it turns negative. I have a positive 24k and a negative 24k, which gives me 0. Or 0k, but that looks like okay, so I'm just going to get the 0. Do not leave it as a positive 1k, right? There's nothing left. There's no number there. There are no variables. It's like saying that you had 24 kazoos and then you lost 24 kazoos. You can't tell me you have a kazoo left over. You lost them all. There's nothing left. Alright, now with my constants, that 132, it's going to cross over, so it becomes negative 132. But my 144 stays where it is, so it stays positive to give me a positive 144. When you combine those, you get 12. So now this is the important part here. Now we have that 0 equals 12. But this is not a true statement. 0 does not equal 12. You can't tell me if you have $0, you have $12. It's not a thing. So when you get something like this, your variable is completely gone. There is no variable left. And you get a false statement. Your answer is no solution. This only happens when your variable completely disappears. So make sure you're super, super careful of that. If, scroll down just a smidge, if we ended up with 12 equals 12, we got a true statement. There's no variables involved, but we got a true statement. That would be called infinitely many solutions, which means that no matter what number we plug in for the variable, everything's going to work. Both sides are completely the same all the time, right? So if you get the same exact number on both sides with 0 variables, infinitely many solutions. If you get 2 different numbers on both sides with 0 variables, there's no solution. Be super careful with those differences. All right, so that's it for this video. We talked about how to distribute and then solve multi-step equations. So until next time, I will see you later. Love you, bye.